Okay, we want to solve this system by graphing and by elimination. This is still giving people too much trouble. Okay, so we have to understand what we're doing. First of all, graphing. Behind it. Okay. Graph a straight line. Let x equals 0 and solve for y to get the y-intercept. Why does that work? Because on the y-axis, x is 0. Now, people are often doing this. I see too much of people doing the procedure without reminding themselves of why they're doing it. That puts a lot of pressure on you on an exam. Because if you're doing that, it means you got to remember the procedure. And if you forget the procedure, you're dead in the water. If you remember why you're doing the procedure, you're less likely to forget steps in the procedure. Okay? If you're not writing out, okay, we're going to y-intercept, x equals 0, and then you do the calculation. Okay? X-intercept, y equals 0, then we do the calculation. If you write that on your paper, every time you do it, it takes only a couple of seconds, and it reminds you of what you're doing and why you're doing it, so you'll remember what to do when you need to do it. Also, so you have more insight into graphing everything else. Throughout the course, we've done a lot of graphing, and when we found the y-intercept, we've let x equal 0, but it hasn't necessarily sunk into everybody why we're doing that. Okay? And the best solution I can suggest to that is write out what you're doing, write out why you're doing what you're doing. You don't have to write a paragraph, just write a reminder. This is why I did this. Okay? That reinforces what you're doing so that when you get to the exam and you've forgotten all the details, you still know what to do. Okay? It's much easier to understand what you're doing than it is to memorize 20 different calculation procedures that get the right answer, but without having any real meaning. Okay, so we're preparing for the exam, which will come up in a couple of weeks here. Try to get in the habit of doing this. Write something down about why you're doing what you're doing, because it'll clarify it for you. It'll make it easier for you to remember. It'll make it more reliable for you to do the stuff. Okay? Okay, so anyway, let x equals 0 and solve for y to get the y-intercept. You don't have to graph this out. I'm writing this because this is something that apparently not everybody is totally grasped at this point, okay? And it doesn't apply just to a straight line. You always get the x-intercept by letting the y-intercept by letting x equal 0. So it doesn't apply just to straight lines. Graph a straight line, to graph any equation. Graph a straight line. Okay, always the same. The graph of polynomial. You let y equal 0 and solve for x. It gives you the zeros and the multiplicities and all that stuff. Okay. So let's do this. Here's y-axis. Okay, our equation. 3x plus 7y equals 19. X equals 0 gives you 7y equals 19. Y equals 19/7. Y-intercept 0, 19/7. Now I know time's important. Okay, you got to balance your time, but the time it takes to write this out, if you know what you're doing, is like 20 seconds. You're not going to save yourself a significant amount of time by skipping the meaning. Okay, it's the number one thing I want to try to get across to you now. Okay, there's still time to focus on meanings because you know how to do most of the stuff. Maybe all of it. Some of you doing quite well with it. And, yeah, some people are doing okay with a lot of it, but there's still some things you want to get straight before we get to the end of the course. So x equals 0 gives you this. So I just wrote this out. Y equals 0 implies that 3x equals 19. And it doesn't hurt to actually write that step. 3x plus 7 times 0 equals 19. To remind yourself what happens when you plug in y equals 0. And you get x equals 19/3 and x-intercept 19/3 0. Okay, well, then we plot two intercepts. 19/7 is a little less than 3, right? And 19/3 is a little more than 6. So we'll go at least 6 in this direction. Okay. We don't need to go too much further than that. Now we can take our second equation. Ever write out the equations? Okay, well, let's just slob it in there. 7y equals 19. And let's put a number in for b and make out 5 and make out 4. Okay, so here's our first equation. If we look at the second equation, we can see that when y equals 0, x is going to be 14/6, which is less than 2. And we can see that if x is 0, y is going to be negative 14/5, which is about -3, close to -3. So we don't need to go out to 300 on our x-axis and up to 700 on our y-axis, right? We don't need to go to big numbers. 10 would be plenty. 8 would be enough, okay? There are no intercepts that exceed 8, and 8's an easy number to use because we can easily subdivide it. So let's go 8 and 4, and 2 and 6, and -8, -4, -6, -2. We'll go up to 8 here. We'll have 4 here, 2 here, 6 here. We'll go down to -8. Then we can take off our 1. And now we've got a graph with a reasonably consistent scale that we can probably use to get a decent approximation of our solution. So we plot the intercepts here. They're going to be 0.19, okay? 19 is a little less than 3, so I'm going to say it's about here. And then our x-intercept will be 19/3 0. That's going to be about 6 1/3 0. We label these things. We label this graph as (3x + 7y = 19). And then we do the same for this graph. Now, I'm not going to write it all out, but you would write it all out this way if you want to reinforce and actually learn as much as you can by doing this problem. Okay, you write it out. If x equals 0, you're going to get -5, y = 14, so y = -14/5. So you get 0, -14/5, which is a little less than, a little above 0, -3. So this is 0, -14/5. And then if y is 0, x is 14/8, which is 7/4, 7/4, 1 3/4. So here's your point. Seven, 4, 0, which is your x-intercept. Now we can draw a line through these points. I kind of missed. So I'm not going to have a huge amount of faith in my result, but it looks like x is about 1, 2, 3 here, and y is about a little less than 2. So I'm going to say that this point is solution point about 3, 3/2. And we check that. Check our approximate solution. We plug in x equals 3, and we get 9 here, right? We plug in 3/2 for y, we get 10.5, and we get 19 on this side. We get, 19.5 here, we get 19. I'm going to write that out in a minute, but you understand what I did. I just plugged these numbers in. 3 for x, 3/2 for y, and I got 19.5 = 19, which means I'm pretty close to my solution, at least as far as this equation is concerned. Let's see how bad it comes out if I plug into this equation, okay? If x is 3, I get 24 here. 3/2 of 5 is 7.5. I subtract 7.5 from 24, I get 16.5. Well, I didn't do quite as well, but it's still reasonably close, okay? Now, I already said that, I kind of missed this point. This point's a little too far to the right, so it should be a little further to the left, which means my y should be a little bigger, my x should be a little smaller. Of course, that would make this one even worse, so I don't know. Well, it's a hand-drawn graph. It's close enough to give me a pretty good indication of what my solution ought to be. Now, I do that before I solve it, so I don't know in advance where this point should be. Because I already know where that point should be and I'm wrong, I'm going to somehow fudge this around to make it look right. And I'm not going to have a check. I'm not going to have a consistency check. And I'm not going to see the geometry. Okay, so at that point, okay, so the graphical solution Okay, putting into our equations, we get 3 times 3 plus 7 times 3 halves equals 19. And we get 8 times 3 minus 5 times 3 halves equals 14. Okay, well, that gives me 9 plus, I'll just say 10.5 equals 19. And 24 minus 7.5 equals 14, which gives me 19.5 equals 19. So far I was thinking I was doing pretty good, but then down here I got 16.5 equals 14, which is not bad, but not nearly as good as this. So we, and keeping with the idea of writing this out, we did was we plugged in x equals 3, y equals 3 halves. Okay, doesn't take long to write that out. It reminds you what you're doing. Now we solve by elimination. There are other ways to solve the equations. The only way I'm going to test you on is elimination. We call this equation 1. We call this equation 2. Then what I'm going to do is I'm going to write out -8 times equation 1, 3 times equation 2. Why? Because that's going to match up my x's. That's going to give me -24x minus 56y equals 152, -152, because 8 times 20 is 160, subtract 8, you get 8 times 19. Okay, so we get down here 24x, then it's going to be minus 15y equals 42. Then we add equation 1 to equation 2. Equation 1 now referring back to the first of these two equations, equation 2 to the second, okay? Then I get 0x minus 61y equals -110. So that y equals 110 over 61. It's a little bit less than 2. Is that consistent with what I had here? Well, I got the estimate, what is it? 3 halves for y, right? One quarter here was 3 halves, which is a little less than 2. Okay, a little too much less than 2 probably, but still not awful bad. Okay. And now what do I do? Well, I've got y. I can plug that y back into either of these equations to solve for x. Okay, so let's plug it into 3x plus 7y equals 19. I'm going to get in some inconvenient arithmetic, but I'll live with it. I'll probably make a mistake. You can check it. Okay, so you get this. What do we do to solve this? I don't want to mess with common denominators. I just multiply out by 61. I get 61 times 3x plus 7 times 110 equals 19 times 61. Didn't write out all the details. I multiply this by 61. That 61 will divide by this 61, leave me 7 times 110. Make sure you understand how that applies the rules. And I get then 183x plus 770. And oh boy, I get to multiply 19 by 61. Well, it's not too hard. 20 times 60 is 1200, right? So 19 times 60 will be 1200 plus 60 will be 1140. And then 19 times 61 will be 19 plus that will give me 1159 if I did that right. I don't know, I'm not counting on it, but if it's not right, it's close. Okay. Then I get 183x. I'm skipping the algebra steps. I'm not going to write out all that in detail, although I've been doing so practically all semester. Your algebra should be totally up to this by now, and I think it pretty much is. Okay, now I subtract 770 from 1159. That's a little bit dangerous. 770 and 400 is 1170, and that's 11 less than 400, so it maybe be 389. Now, if I'm getting this right, it's just by dumb luck, but we get x equals 389 over 183. And that's reasonable because I estimated about 3. Well, I was a little too far to the right, and really, wait a minute, I'm not sure I like that, all that. Let's see. Yeah, 389. Yeah. Okay, that's just a little more than 2. I'm not sure that's going to get me where I want to go. So there might be a mistake in that. But that would be my solution. I'm not going to go through all the details of checking the solution. I'm not all that happy with what I've seen. That'd be close. Okay, then I could check. I put these fractions into this equation here and work it out. Or depending on what I'm trying to do, I could do it decimal equivalent. You know, that's about 1.8. That's about 2.2. Okay. Plug in 1.8 and 2.2. That actually works out. No. This is 1.8 and this is 2.2. 1.8 times 7, 2. That could work. And 1.8 here would give me 9, and 2.2 there would give me about 19. No, that doesn't work. Yeah, well, probably not accurate, but that's a process. Okay. Now this happens when you use random numbers, you get nasty fractions. Okay. And your test, your exam will use random numbers. Sometimes they're generated so they won't be too bad. And sometimes they're generated so they'll be whatever you get. Okay. I'll remind you that on the exam, you can't take your graphing calculator in. Can't use a graphing calculator. Use a calculator. The testing center gives you just a basic numerical calculator, okay? But you'll have that. And I also advise people go in and familiarize themselves with it. And I think people pretty much did that in the midterm. So should be okay with that. If you have a system with 3 equations and 3 unknowns, and let's just say it's two x minus 7y plus 15z. Let's see, what do I want to let that equal? I want to let that equal 12. And four x plus 3y minus 5z equals 6. And this. Okay, what are you going to do with this? Well, now you don't always eliminate x. Sometimes it's easier to eliminate y or z. I set this up so it's easy to eliminate x. Your open math will, show you alternatives, and we want to get a basic method, get the basic idea down, okay? So what multiple of equation 1 would I want to add to equation 2 in order to eliminate x? And what multiple of this one would I add to this one to eliminate x? Okay. I'm going to make it, no, I'm not. Okay, well, I'm going to demonstrate. Then I'll give you one to work out, okay? Don't necessarily want to demonstrate in this one because I made up the numbers so they'll work out. So let me demonstrate with another system. Come back to that system. That's what I want you to work on. Let's start from the left. That's the way we usually do. Okay. So let's say I've got okay. So I made up the numbers on the equation I'm having you work on so that it works out kind of nicely if I did everything right. This one is not going to be the least bit nice. I don't expect it to be because I just put down random numbers. Okay, so I got equations 1, 2, and 3. Okay. If I add -3 times equation 1 to equation 2, that's going to get rid of the x, isn't it? It's going to give me -6x, and we still have 6x here. -3 times equation 1 is -6x minus 15y plus 21z equals -12, assuming I did that right. Okay. Equation 2 is 6x plus 3y minus 5z equals -7. I add them up and I get -12, 12y plus 16z equals negative 19. Okay. Then I'm going to eliminate x between the first and the third equation. So I'm going to do negative 5 times the first equation and 3 times the third equation. That's going to give me negative 10x minus 25y plus 35z equals negative 20. 3 times the third equation is going to give me 15. Why would I multiply that by 3? 2 times the third equation, sorry. I had 3 for the third equation in my head, and I wrote down 3 twice. Okay, so 2 times the third equation is going to be 2 times 5 on the x, gives me 10, and minus 4y plus 8z equals 24. When I add these up, I get negative 29y plus 33z equals 4. Okay. Too many prime numbers floating around there, so it's going to be kind of ugly. So now I've got a system of 2 equations. I get equation negative 3 times equation 1 plus equation 2 gives me negative 12y plus 16z equals negative 19. And I get negative 5 times equation 1 plus 2 times equation 3, which is negative 29y plus 33z equals 4. Okay. Now, I can solve this system of 2 equations and 2 unknowns. I'm going to get a y and a z. Okay? And I'm just going to use the process of solving 2 equations and 2 unknowns. I'm going to get y and z, which I can then plug back into any one of these equations and solve for x. So I'm not going to do that. That's the process. I'm assuming you know how to solve 2 equations and 2 unknowns. Okay. Now, I think the equations that you get if you follow this process over here are going to come out with much nicer numbers, because these numbers are not nice at all. I wouldn't want to even, I mean, I could attempt to do this in my head. My chances of getting it right wouldn't be all that great. And of course, I could do it with a calculator, but you know, practically, that's not really what you would do. If I was doing it, I'd use matrix methods and probably a computer. Calculator would do it too. Computers are easier because you can type on them. Okay, well, anyhow, let's follow the process. I get choked up when I talk about this. I love it so much. Okay, sorry, it's allergy season. Okay, we're going to solve this. And I'll just kind of circulate around, see how you're doing, come up to the board for something I need to say. Fair enough? You know, one thing you want to notice is that I calculated this off to the side someplace because I don't want to clutter up the progression of the solution, okay? This is the side calculation where I do -3 times this equation plus 2 times this equation. I write it off to the side. If I'm good enough to do it in my head, I could actually do that in my head, but I'd be more prone to making mistakes. It's a good idea to write it out. Okay, and then the process step where I eliminated the x from the first and third equation, I wrote over here, not down below this. So what I want to write here is the steps that actually show the progression of the solution, okay? So do side comments off to the side someplace. Okay, everybody seems to be off to a pretty good start on this. You gotta be careful. You gotta look at what the open math tells you. We're out of time, so we don't have time to wrap this up. But a couple of people have totally finished it and a lot of other people are right on track, okay? You gotta be real careful with your arithmetic. It's not gonna work if your arithmetic isn't right. So be sure you check yourself, okay? The open math should get you through this. Hopefully it will, so that next week we can concentrate on some review, some things you still have questions on, some things you need to see reinforced, okay? So we don't want to spend too much time on this, but we'll spend a little bit of time on it to make sure everybody's able to do it, because this is a simple mechanical procedure. Once you get used to it, you shouldn't have a lot of trouble with it. Okay, very good.